Hello, my lovely students. Hope you're all doing well. This is the second part of lesson 10.4 in your book regarding double and half angle identities. Last time we spoke about double angle identities. This time I will discuss half angle identities. So we have fixed ones. Half angle identities for sine theta over 2 would help me, for example, get a sine 15 because I know sine 30. Half of 30 is 15. See, over here it's theta over 2, but here it's plus or minus 1 minus cosine theta over 2. So this is double this. So if I want to get 15, I will deal here with 30, and I know 30. Cosine theta over 2. Let's say over here again I want to get cosine 15 and I don't have a calculator, I'm in the desert. I can use this identity, cosine theta over 2 plus or minus 1 or plus cosine theta over 2. Again, this is double this. So if I want 15 here, I would use 30 here. If I want, for example, let's say 45 here, I would get 90 here, and so on. For the tan, in your Algebra 2 book, you only have this one, but we have the other two in the Precalculus book. So tan theta over 2 is equal, we have three others, we can drag them if we need to prove, but we don't need. One of them is plus or minus root of 1 minus cosine theta over 1 plus cosine theta, and the other one without this is a root, and plus or minus depends on the quadrants. And here tan theta over 2 is equal to 1 minus cosine theta over sine theta, and there's another one, sine theta over 1 plus cosine theta. When will I use this or this or this? Depends on the question. When you're solving or you're verifying, do I need a cosine, do I need a sine, do I need only a cosine? Depends on how you look at the question. Of course, here cosine cannot equal to negative 1, sine cannot equal to 0, and cosine cannot equal to negative 1. I will solve couple of questions from pre-calculus, and then I will start solving from Algebra 2 as well. I discovered that I've been solving the couple of previous days, and solving is, by the way, lesson 10.5 in your book. So you will have an idea about solving when I reach that. Promise you, these are the last identities. Just memorize all these identities. I'm giving no new identities again, although there is, but I'm giving no more. In the Precalculus book, the first questions are asking us to let me check the book. First questions are asking us to find the exact value of each expression. Find the exact value of each expression. Find the exact value of each expression. And again, I have no calculator with me. This will be so helpful because 29 they want us to find sine 67.5 degrees, and I don't have 67.5 on my unit circle. So what can I do? I can deal with its double. So my first step, okay, is to think what is 67.5 times 2, because I think this is half of something on the unit circle. It's 135 degrees. My second step is to think of this identity, sine theta over 2 equals plus or minus root of 1 minus cosine theta over 2. Again, do I need plus and minus here? I already know if this angle is in quadrant 1, then the answer is positive for everybody, and for sine it's positive, so I don't need this right here now. Okay, here probably I would use 135, and here probably I would use also 135. So how I'm thinking of sine 135 divided by 2, isn't this equal to sine 67.5? It's equal to sine 67.5. So there's no problem to use sine 135 over 2, or to use theta as 135. Okay, then this is equal to root of 1 minus cosine 135 over 2. What will I do next? I can evaluate cosine 135. It's a cosine, it's a quarter in the second quarter, right? In the second quarter, cosines are negative, and it's root of 2 over 2. So this is equal to 1 minus negative root of 2 over 2 over 2. خلاص, we're done. It's a matter of simplifying, okay? And you can check with the calculator from the beginning. From the beginning, the answer will come on the calculator to be 2 root of 2. No, the calculator will not give you this answer. The calculator will give you 0.923. But you can check that this, whatever we'll stop at, is equal to this in decimal form. Here I'm 1 plus root of 2 over 2 over 2. Okay, I cannot add these because they're not equal denominators. This, I have to multiply it by 2 over 2. So I will have 2 plus root of 2 over 2. Yes, all over 2. Everybody's under the root. Okay, what's my next step? My next step is to drop the 2 down as a multiplication. So your final answer for sine 67.5 degrees is 2 plus root of 2 over 4. Okay, but I know root of 4, so I can leave it like this. 2 plus root of 2 over 2. And it's not plus or minus because it's already in quadrant 1. And this is the final answer for it. So with the help of 135, I was able to find 67.5 or sine of 67.5, and this is the job of half angle identities. Okay, the next question is question number 30. It says cosine pi over 12, and I wish you remember what is pi over 12. Pi over 12 is 15 degrees. You want to deal with the question in degrees, I don't mind, but we need to train ourselves, okay? So first step is to get double pi over 12, which is pi over 6 or 30 degrees. Second step is to say this identity, cosine theta over 2 is equal, command this is in quadrant 1, but it's positive anyways, 1 plus the same rule but plus cosine theta over 2. So I'm going to use this as theta. Okay, so cosine pi over 6 over 2. If I want it in degrees, it's cosine 30 over 2, which is cosine 15 degrees, which I want. يعني هنا cosine 15 degrees is equal to this. وهنا cosine pi over 12 is equal to this. Okay, I will proceed. Over here I'm 1 plus, I'm using 30 degrees. Cosine 30 degrees is root of 3 over 2. So 1 plus root of 3 over 2 over 2. My next step is to multiply here by 2 over 2 to make the denominators equal. So I will reach 2 plus root of 3 over 2 all over 2. Everybody's under the root. Again, I will just keep repeating the steps. I will take this 2 down, so I am left with 2 plus root of 3 over 4. So the final thing is cosine pi over 12 is equal to root of 2 plus root of 3 over 2. Your calculator will give you root of 6 plus root of 2 over 4. And anyways, these two are equal. Try this as a decimal and this is a decimal, you will notice that they are equal. The next one is question number 31. They want tan. I'm trying to display all of the identities. Command, we don't have an idea about 157.5. 157.5 times 2 would give me 315. 315 is on the unit circle. Number 2, which one would you use? I would use any one. Now I would think of tan 315 equals to 1 minus cosine theta over sine theta. This is the same 315 divided by 2, I'm sorry. It's the same as tan 157.5. So now since theta became 315, I'm going to say that tan 157.5 is equal to 1 minus cosine 315. Here I put the double, here I put the half, all over sine 315. This is a quarter in quarter 4, where root of 2 over 2 are the answers. Hina positive, hina negative, right? if you still remember the unit circle. Anyway, so I have 1 minus root of 2 over 2 over sine 315 is negative root of 2 over 2. Now it's just a simplifying job, right? طيب, what will I do? Firstly, I'll multiply by 2 over 2 to be able to make the denominators equal. So 2 minus root of 2 all over 2 divided by negative root of 2 over 2. I can cancel this with this, and I'm left with 2 tan 157.5 is equal to 2 minus root of 2. We do not like roots in the denominator, and just to make this 1 and to make this positive, I can do another thing. I can multiply everybody by negative root of 2 over negative root of 2. Not to do another step up to get rid of this negative, I multiplied by negative here. This is going to give me negative 2 root of 2, and these are going to give me positive 2 over here root of 2 times root of 2 is 2, and negative times negative is positive. So I have a 2. I can still do one more step, which is divide everybody by 2. My final answer will be 1 minus root of 2. And you can check with the calculator anytime that this is the right answer for tan. Just make sure the calculator is on degrees. 157.5. This is question 31. Question 32. It's in radians. Again, I don't have 11 pi over 12 on my unit circle. If you change it to degrees by multiplying by 180 over pi, you know that this is 165. So my first step is to do 165 times 2 is 330, and 330 is a peaceful one. So 11 pi over 12 multiplied by 2 will end up in 2 over, this is going to be 6 after simplifying 11 pi over 6. 11 pi over 6 is 330. So number 2, I want sine 11 pi over 6 divided by 2, which is sine 11 pi over 12. Type the sine, we said it's root of 1 minus cosine. Here I'm gonna put 11 pi over 6. 11 pi over 6 over 2. Okay, over here the value of 330 cosine is root of 3 over 2. You can check with the unit circle. 1 minus root of 3 over 2 over 2. Simplifying 2 over 2. I will have a root of 2 minus root of 3 over 2, and everybody over 2. Again, the same things will keep repeating. Take the 2 down, you will have root of 2 minus root of 3 all over 4. I can further simplify this to 2 minus root of 3 over 2. And this is sine 11 pi over 12 equals to this. So by double it, I can use half angle identities to help me find the value. We can have questions which are asking for solving, as I said, and they gave me the interval, solve each equation. Now any identity can come from the beginning until the end can come. You should know how to manage all of them together. Since they wrote from 0 to 2 pi, this means I am just on the unit circle. I'm not adding any more rounds. This is what they mean. Question 33 is asking me for sine theta over 2 plus cosine theta equals to 1. As I said, when they say solve, it means find theta, and you will need to refer to the unit circle at the end. Okay, so what shall I do? This is a half angle identity that I know. It is root of 1 minus cosine theta over 2. Here I don't care about plus and minus anymore, okay? It's just root 1 minus cosine theta over 2 plus cosine theta equals to 1. I think I need squaring somehow here. Okay, I will send this out first, because if you square, you cannot square this alone and this alone and this alone. You will square both of these together and you will have trouble with the middle term. So I will just send this out for now and think of the question in this way. Equals to 1 minus cosine theta. A step that I need over here now is to square this side and again square all of this side together. Squaring this side would just remove the root. I will have 1 minus cosine theta over 2. Here I have a middle term, it's a trinomial. 1 squared minus 2 times a times b, so 2 cosine theta, plus squaring this one would give me cosine squared theta. A perfect step now is to multiply all of the equation by 2 to get rid of this. Multiply by 2, or take 2 to this side, then you'll have 1 minus cosine theta equals 2 minus 4 cosine theta plus 2 cosine squared theta. So 2 cosine squared theta, if I take this here, I'll get minus 3 cosine theta. I think factoring is coming soon. I can open two brackets, one called 2 cosine theta and here cosine theta. Remember, I'm solving. Minus 3 and here a plus would give me a minus 1 and a minus 1. So once, maybe zero product property, maybe this one is equal to 0, so cosine theta is equal to half, and maybe cosine theta is equal to 1. You can substitute your answers at the end and check that you are right. When is cosine theta equals to half on the unit circle? It's at, you can check with the unit circle, it's at 5 pi over 3 and pi over 3. This is where cosine theta is equal to half. Cosine theta is equal to 1 at theta equals to 0. So you have three answers, 0 and 5 pi over 3 and pi over 3. Please keep your unit circle beside you so you can refer to it. Question 34. Again, is a solving question. Tan theta over 2 is equal to sine theta over 2. And we need to know what is this theta that will make these equal to each other. Okay, I think for the tan, I would go to the one that has only cosines because this is going to change to a cosine, right? This is 1 minus cosine theta over 2. And I have one identity here that is 1 minus cosine theta over 1 plus cosine theta. So I don't want to have sines and cosines. What will I do now? I think I should, the way you deal with numbers, you deal with trigonometric functions or identities. This will cancel the root and this will cancel the root. You have 1 minus cosine theta over 1 plus cosine theta equals to 1 minus cosine theta over 2. I could cross multiply or just think simply, if these two are equal to each other, then definitely these two are equal to each other. And if I have 5 over 4 equals to 5 over x, what will this x equal to? It has to be 4 as well, right? So I can just directly say that 1 plus cosine theta is equal to 2. So cosine theta is equal to 1. When is cosine theta equal to 1? At theta equal to 0. And you're done with this question. And you can substitute and check. Okay. Question number 35. I hope the camera is getting everything. Yes, inshallah. So 2 sine, see, I fixed it this time better. My husband helped me with that, actually. So this one, I know it, it's 1 minus, so I have 2 and root of, don't forget the root, 1 minus cosine theta over 2 for this equals to sine theta. If I square, I'm gonna square both sides. If I square this side, I will have to square this side as well. 2 squared is 4, and this, when I square it, I will just remove the root. Here, the squaring, we write it this way, sine squared theta. This with this will give me 2. Multiply 2 by 1, that's 2. 2 by this, minus 2 cosine theta. I think it's right time to change this to 1 minus cosine squared theta to have them all in cosines. 1 minus cosine squared theta. I would prefer to keep this positive, so I'm going to take it to this side. It's going to be cosine squared theta minus 2 cosine theta minus plus 1 actually equals to 0. The brackets are cosine theta, and I think both of them are minus 1. So when is cosine theta equal to 1? Again, at theta equals to 0. So these two are equal at theta equals to 0, and these two are equal at theta equals to 0. Okay, we'll go more into details of solving when we come to lesson, as I said, 10.5. I will have a couple of questions to verify from your Algebra 2 book. From Algebra 2, I guess I will tell you the page. Alhamdulillah, I closed the page. 10.4. Okay, the verifying questions are in page 680. Okay, question number 26 is the first one for verifying. Number 26, or the question is saying verify each equation is an identity. Okay, for question number 26, tan 2 theta is equal to 2 over cotan theta minus tan theta. As we said before, in verifying, your job is to either work on this side or work on this side or work on both. As long as you verify that the left side is equal to the right side, it's okay. For me, I think I worked for both. I changed this one to double angle identities we took in the previous video. 2 tan theta, I cannot say in the previous class anyways, 1 minus tan squared theta. Okay, working on this side, I can say it's 2 over 1 over tan theta minus tan theta. I can multiply by tan theta over tan theta. Why? To make the denominators equal. I will reach 2 over 1 minus tan squared theta over tan theta. I think it's obvious by now. I will take the denominator of the denominator upwards, so I will have 2 tan theta over 1 minus tan squared theta, which is equal to 2 tan theta. Here I proved it. You can prove it your way. I proved that this is true by simplifying the left side and the right side. This is regarding 26. 27, the question is 1 plus half sine 2 theta equals to sec theta sine theta all over sec theta. Okay, double angle identity. Okay, I think I did both sides as well. Here's 1 plus half sine 2 theta, I explained last time, so 2 sine theta cosine theta. This will cancel this. This side became 1 sine theta cosine theta. Let's work on this one. It's 1 over cosine theta times sine theta over 1 over cosine theta. I can cancel this with this, and I am left with actually, just a second. No, the question is not like this. The question here is an addition, so I cannot cancel anymore. Okay, it's plus. My coming step is to multiply by cosine theta over cosine theta. Why? To make the denominators equal. So I would get 1 plus sine theta cosine theta, it started showing, over cosine theta over 1 over cosine theta. Now denominator and a denominator can cancel each other, and you're left with 1 plus sine theta cosine theta, which is equal to 1 plus sine theta cosine theta. And I proved it. I hope you're understanding. Question number 28, sine theta over 2 cosine theta over 2 equals sine theta, all of it over 2. This is half angle identity, and this is half angle identity, which I know. This one is root of 1 minus cosine theta over 2 times. This one is 1 plus cosine theta over 2. And here is still sine theta over 2. Okay? What will I do? If I multiply this by this, I can put them both in one root as 1 minus cosine theta. I'll go step by step. 1 plus cosine theta over 4 sine theta over 2. What am I supposed to do? I'm supposed to square this side and square this side. صح? صح. So now I have 1 minus cosine theta times 1 plus cosine theta over 4. The root will get cancelled with the square, and that's it. Do not do anything in the inside. Equals to sine squared, we write the squared here, over 4. It's getting clear now. If I multiply these, I would do first with first, last with last, because it's difference of squares. So 1 minus cosine squared theta over 4 equals sine squared theta over 4. And what is 1 minus cosine squared theta? Pythagorean identity. And here I worked on both left side and right side, and I proved it, right? Okay, that's it for now. I will send you a homework sheet to solve, and I hope I made it clear for you. We're left with only one lesson in these identities, and then we'll start reviewing, inshallah. Bye, love you.